Select the IUPAC name for the following molecule. When we look at this molecule, we see that we have two different functional groups. We have an alcohol and we have an alkyne. When we have a molecule that contains two different functional groups, we need to know the order of priorities to know which functional group we should number to give the lowest number. So from table 7.1 in your textbook, you have a rough listing of priorities. Carbonyl-containing compounds are the highest priorities. You will learn how to name those in Chem 100. After that, we see alcohols having a higher priority than our multiple bonds. So for this example, we will number to give the alcohol the lowest possible number, which means we will start numbering on the left. So this gives us 9 carbon atoms in our parent chain. We see that the alkyne starts at carbon 6 and our alcohol is at carbon 3. The alcohol has the higher priority, so we will put that at the end of our name. So we have then as a parent chain known for 9, 6-ine to show that the alkyne starts at carbon 6, 3-all. In looking at the substituents, we see at carbon 2 that we have a methyl group, and we see at carbon 8 that we have another methyl group. So we will say that this is 2,8-dimethyl, known 6-ine, 3-all. So 2,8-dimethyl. And so all that remains to figure out this name is to assign the stereochemistry at the chiral center at carbon number 3. So at carbon 3, we can see 1, 2, 3 bonds to that carbon atom. The 4th bond is understood to be hydrogen. We will always have 2 bonds in the plane, 1 sticking out of the plane and 1 pointing back. So that tells us that the hydrogen must be on a dash bond. Hydrogen having the atomic number 1 will be the lowest priority, or priority number 4. And then we need to assign priorities to the other 3 bonds to this carbon atom, to carbon atom 3. So we have a bond to carbon, a bond to carbon, a bond to oxygen. Oxygen has the highest atomic number, so that will be our highest priority. The 2 carbon atoms, because they're both the same atom, have the same atomic number, so we next need to see what those carbon atoms are bound to. So we're comparing the carbon 4 and the carbon 2. If we examine carbon 4, we have 2 bonds to carbon, and the other 2 bonds then are understood to be hydrogen. If we look at carbon 2, we have 1, 2, 3 bonds to carbon, and the last bond is to hydrogen. Here is our point of difference right here, carbon and hydrogen. So the carbon at carbon 2 will have a higher priority, so we will say 2, and then carbon 4 would be priority 3. So now what we need to do, make sure your lowest priority group is pointing away from you, which it is. So then we're going to draw an arc from 1 to 2 to 3. And we see that that arc is proceeding in a clockwise direction. So this is an R stereocenter. So this molecule is R, 2,8-dimethyl, known 6-ine, 3-all, which is option C.